friends, today I will discuss some problems regarding the rotational motion. And rotational motion I had already completed, and specifically the rolling part is very important, and I have already discussed everything on the concept of rolling motion. So today we are going to discuss some important problems which are very much related to JE main and JE advanced. So you have to watch very quick concentration. You have to watch the video with very concentration, and let's just start with the first example on the basis of concept of rolling motion. So rolling motion is the concept we are going to apply here, by which we can solve this problem. Okay, that is very important question. So that is a sphere I am taking, having mass m. The mass of this sphere is m, and radius of this sphere is r. Okay, now two plates are placed over the sphere and below the sphere, and two plates are having different velocities, that is 3v, that is v. That is given in the question. Okay, that is already given in the question. Now you have to find what is the requirement of this question. The main requirement is that at that condition, if the sphere is rolling between these two plates, if this sphere is rolling between the two plates, so what will be the angular velocity, and as well as what will be the linear velocity of the center of mass. So the question is that, again I am repeating, if the rolling motion is happening between these two plates, so what will be the angular velocity of this sphere, and what will be the linear velocity of the center of mass of this sphere? That is the question. Okay, so if the velocity of center of mass is v, and suppose omega is the angular velocity of this sphere, so now we have to find what is the linear velocity, what is the linear velocity, and what is the linear velocity and angular velocity of this sphere during rolling motion. Now this is the question. So from the point of view of the concept of rolling, these are the 2 points, and you have to separate this picture into 3 pictures. Let's see. Separate. That is a separate body. That is a separate body. That is also the separate body. This is a contact point P. This is the contact point P. This is the contact point P. This is also the contact point Q. This is contact point X. This is contact point Y. If the and this is the velocity 3v, and this is the velocity v, and this is the velocity, suppose this is v1, that is the velocity of the center of mass of this sphere, that is v1, and that is the angular velocity omega. So what will be the velocity of the point Q? Net velocity is net velocity. What will be the net velocity of point Q? That will be written as VQ. We can take the VQ as a reference velocity of the point Q. So what will happen? You all know that if the velocity of the center of mass V1, so the velocity of the Q point will also be same, that is V1, and at the same time there will be a tangential velocity because of the angular velocity. So there are two velocity. One because of the rotational motion, another one because of the translational motion, and this motion is known as rolling motion. You already know rolling motion is the summation of two different motion, rotational and translational. So the velocity of point Q, that can be written as v1 plus the, what will be the value of tangential velocity, that is omega r. Omega r, this is also in the same direction, v1 plus omega r. So I am taking v1 in this direction and I am taking omega in the clockwise direction. That doesn't mean whatever the direction I have been taking, it will be the correct answer. If this is not the correct answer, then what will happen? Whatever the answer I will found, if this is in the anti direction, according to the direction I have been taken, that has been taken by me, that will be, and then the answer will be in a negative. So that means if this is a positive I have been taking, if actual velocity suppose in this direction, so v1 will become as a negative value. The value will be negative. So I am taking as a v1 as a positive in this direction. I am taking this positive direction, and clockwise direction I have been taking as a positive direction. If the actual angular velocity is in anti-clockwise direction, then that means the answer will be negative. So negative implies the actual direction. Okay, negative implies the actual direction to which, negative implies the actual direction to which direction I have been taking its opposite direction. So that means again, what will be the net velocity of x? Again I have to find the velocity of x. Net velocity of point x. Let's take it as a vx. The velocity of the center of mass is v1 in this direction. So you know that according to the concept, this point will also be have the same direction, that is v1. This point will also have the same amount of velocity v1 in the same direction, and there will be an additional tangential velocity because of the rotational motion, that is omega r. But v1 and omega r in this case both are in opposite direction. What will be the net velocity? v1, because I have taken this direction as a positive, this direction taken as a positive, so v1 minus omega r. Okay, but whenever the rolling motion is happening, that means the main important point you have to remember, these 2 points will have the same velocity, these 2 points will also have the same velocity. So that means you can write from the condition of the rolling, from the condition of the rolling, motion, we can write, what we can write, Vp, that should be equal to Vq, and Vx, that should be equal to what? Vy. These two conditions must be fulfilled if there is a rolling motion happening. Right now the rolling motion is happening, that is already mentioned in the question. So that means these 2 points will have the same velocity. So that means Vp should be equal to Vq and Vx should be equal to Vy. Now what is the velocity of P point? The velocity of P point will be equal to the velocity of this plate, that is equal to 3v. So from here we can write, what is the velocity of P point? That is equal to the velocity of this plate, that is equal to 3v. So Vp means 3v. That should be written as a, that should be written is equal to Vq. What is the velocity of Vq? V1 plus omega r. And that is the first condition. Second, what is the velocity of y point? The y point will have the velocity that should be equal to with the velocity of this lower plate. What is the velocity of this lower plate? That is equal to v. So what is the velocity of vy? That should be written as a v, and that should be equal to the velocity of x point. So what is the velocity of x point? That is v1 minus omega r. That is the second condition. Okay, up to this everything is clear, my student? Okay, so let's move forward. let's move forward. What is our unknown value? That is V1 and that is omega. Two unknown, two equation. So by adding these two equation, 1 plus 2, so we can write 3V plus V is equal to 2V1, and plus minus that both will be cancelled out. 2V1. 4V, that should be equal to 2V1. V1 is equal to 2 into V. V1 is equal to 2 into V. Okay. Now we had a, what is the value of linear velocity of the center of mass? That is equal to 2V. Now what will be the value of omega? So put the value in the equation, putting the value of V1. Now the next criteria is to find the value of unknown quantity, that is omega. Already we had find the value of V1. So putting the value of V1 in equation, you can put the value either in 1 or either in 2. So I am putting the value in the equation of 1. So what will happen? That will give you 3V. What is the value of V1? That is 2V. What is the value of omega? Omega R. Okay. What is the value of omega? Omega R. So that means 3V minus V. 3V minus 2V V divided by R. So that is omega. Okay. So this is the answer, omega. But let's see, V1 is 2V and omega is V by UR. Both are the right answer. And one thing is to be mentioned here, both are having the positive value. So that means both are having the positive value. That signifies whatever the direction I had taken, that direction is completely correct. If the answer comes in the negative value, that means you have to understand whatever the direction I had taken, either it may be clockwise, it may be anti-clockwise. That means the answer should be, or actual direction should be, the opposite of granted direction. Granted direction means whatever the direction I had taken. Okay, so both direction of the angular velocity is in the clockwise direction and the direction of linear velocity is in the positive direction. That means in the right direction. Okay, so this is the answer.